Welcome back. We're continuing our work on sum and difference identities. The last video we looked at some examples of how we can actually look at a trigonometric kind of question and simplify or expand by understanding how these identities link to the question itself. Another good thing about identities is we can take simple questions that look like this and find out what those exact values are going to be. Now, when it comes to the exact values, the most common ones that we come across are known in your unit circle. So for instance, or your right angle, your special angle triangle. So we have 60, 30, 90. We also have 45 as well. So we can look at these types of questions that, you know what, a lot of the times we can make up the answer to this by looking at numbers that are common. So common numbers are be like 60, 30, 45, 45, 90, 120, 150, as long as they're numbers on the unit circle. So for instance, if I had 15 degrees here, I could break this down as being 45 minus 30. Because I've got a 45 and I've got a 30. Where if I had 105, this could be broken down to, well, 60 plus 45. They're common values that we see a lot all the time. 30, 60, 45. And we're going to be using this kind of understanding to help us solve the next type of questions. So let's leave this here for a second and let's look at this question that we have up on the board. We want to solve finding the exact value. So this time we want to solve into two coordinates. What is the value of sine 75? Well, another way that I can write sine 75 is sine, and I can break it up into two parts. So I can break this up into either 45 plus 30 or 30 plus 45. Generally we try and go from a higher to a lower, it kind of gives us what we're looking at, but in this case, as long as these two are adding up to 75, we know we're on the right track. We wouldn't have something like 55 and 20 because I wouldn't know what those exact values are on the unit circle. So that's why we're using values that are common. And you're going to see that in a second now. So this here will then become, well, I've got sine 45 plus 30. I've got an identity here. Here's A, here's B. I can now use this kind of rule. So I can have sine 45 cos 30 plus cos 45 sine 30. And now it's just a matter of working out, well, what is sine 45? What is cos 30 in its coordinate form? What is cos 45? What is sine 30 here? So we know that sine 45 would be 1 on root 2. And we're going to multiply that with cos on 30. So cos on 30 would be 1 on 2. Because remember, if you're going over 60, the lowest part is going to be root p on 2. So then we have 1 on pi on 2 times root 3 on 2. Because remember, if we go back to what we had before a couple of videos ago, we could work out that pi on, when cos equals pi on half, sine should equal root 3 on 2. So we've got these kind of pairings here. And now it's just a matter of multiplying them together. So we'll get 1 times 1 is 1 over 2 times root 2 plus 1 times root 3 is root 3 over 2 root 2. Now I can easily add these together because I have the same denominator. So I'll get 1 plus root 3 over 2 root 2. However, when it comes to trigonometric ratios and your square roots, we want to try and rationalize it. And that means get rid of this square root down the bottom. So we times by 2 by top and bottom. And what this does is this times this by 2. So I get root 2. Root 3 times root 2 is root 6. 2, or root 2 times root 2 will cancel out the roots. So I just get 2. So therefore 2 times 2 is 4. So therefore, sine 75 has an exact value of root 2 plus 6 on 4. See you in the next one.